Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi guys. Boleh dengar suara saya? Boleh?
Boleh sir, boleh.
Okay, right. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning to all of you. So that I mentioned yesterday. So today we go for the tutorial 3 tutorial 3. Okay. So okay, so today we focus on the tutorial 3 for AC meters. Okay, hopefully you have this one. So copy for tutorial 3 I will give already given on the WhatsApp group. So okay, so you have to refer this one, tutorial 3. Okay, so we try go one by one. Okay, for the tutorial 3. So tutorial 3 is for AC meters lah. Right, so let's go for the tutorial 3. Okay, tutorial 3, question 1. Okay, you can read this one. So the current through the meter movement is 150 micro amp peaks. Okay, what is the DC value if the instrument use half wave rectification? Right, so the first, okay, this is for question number 1. Okay, question number 1. Okay, so first you have to draw the skirt for the okay, so this is our skirt. Okay, this is our, we use the half wave rectifier. Okay, that means only one. Okay, so this, all right, so this is our VIN. Okay, so and then this is our diode. Okay, this is diode. Okay, so the current will be 100 microampere. All right, so actually from this one, okay, if you use the oscilloscope, so the output will be like this lah. Okay, the output for this one will be like this. Okay, is a AC. This one the alternating current, and then if you use the oscilloscope, measure to this one, so it will be like this lah. Okay, so for the half wave rectifier, so we will be eliminate this negative cycle. So the negative cycle will be eliminated, so it will be like this lah. So this is the output. The output for half wave rectifier. This is input. Alright, so from this one, if using the, you can use the mathematical to derive this one. Right, but for you no need to derive, so just use the formula. Okay, the formula for this one, for current DC equals to 0.318, okay, IP. Okay, this is a standard formula lah. Okay, standard formula, or some normally actually from derivation is the 1/pi. Okay, 1/pi IP. Okay, it's come from this one. Okay, it's come from this equation lah. Okay, for example, like actually this is a derivation. Okay, maybe for example from 1/t. Okay, integration from 0 to t. Okay, this is IP. Put t dt. Alright, from this one derive. Okay, and then it will be at the end, so you can get the IP pi. Okay, so and then when we convert 1/pi will be 0.318 IP lah. Okay, so this is from this one to get this one lah, derivation. So from this waveform, So they get this equation, and then from this equation derive, okay, from 0 to t, okay, and then from 0 to t. So then the last one will be get the output equation lah. Okay, so to find the current DC, okay, using this formula lah, 1 over pi multiplied by IP. Okay, for this case, okay, 0.318 multiplied by 100 micro. Okay, so the current DC will be the answer will be 47.7 microampere. Right, so that is solution number 1. Okay, straightforward using the formula. Okay, formula. This is a standard formula for half wave rectifier. Okay, for to calculate the current DC is the 0.318. That means 1 over pi. Okay, this this 0.318 come from 1 over pi lah. Okay, multiplied by IP. So IP will be given is 150 micro. Right, so that's why the current DC is the 47.7 lah. Okay, microampere. Okay, that is for the question number 1. For question number 1. Okay, so it's come from this one. So this is inputs. Our input will be AC, and then go for diode. So diode, this single diode, okay, will be eliminate this, okay, this negative cycle. So because this diode will be allowed for the positive cycle. So this is for, okay, this is for direction. Okay, that means this diode will be allowed for the positive cycle. That's why we will eliminate the negative cycle lah. So this is the output. When we put the oscilloscope here, okay, maybe we measure using the oscilloscope. So this is waveform we get. Okay, so we have the eliminate the negative cycle here lah. So this is output. Okay, from this output we can derive, okay, using this equation. This is our IP. Okay, for you no need to understand. Okay, so for you just straightforward. For your just straightforward using the formula lah. So how come this formula actually derived from this outputs? Okay, from this equation. So they have the mathematical derivation at the end. So you get this equation lah, 1 over pi multiplied by IP. Okay, multiplied by IP. That is the formula. So just straightforward for you, just straightforward using the formula lah. Alright, so for example like this one, okay, 1 over pi multiplied by 150 micro. So the answer will be 47.7 micro. So that is for question number 1. That is for question number 1. Alright, so next we go for the question number 2. Okay, question number 2, the ensemble meter movement deflects to 0.8 milliampere. Okay, what is the peak value of the alternating current if the instrument use rectification? Alright, so this one we use the full wave rectification. Okay, so first you have to draw lah. Okay, draw the circuit for. Okay, so this is our words. Okay, so we have. Okay, this is a diode. Okay, this is D2. Okay, this is D1. Okay, this is this is D3, and this is, okay, this one D3, this one D4. Okay, so this one go for meter lah. Okay, for meter. Right, so this is a circuit for the full wave rectifier. Okay, full wave rectification. Alright, so the value given is this here, 0.8 milliampere. Okay. Alright. Okay, for this one, using the similar, alright, similar like before this. So if we put the oscilloscope here, So this is our AC. Okay, is our AC output here, and then we use the oscilloscope to measure here this point to this point, so we get like this lah. Okay, so for full wave rectifier, for the negative cycle will be positive. Okay, will be invert to the positive, will be like this lah. The positive will be maintained. All right, so the negative will be positive. So this is the output for full wave rectifier. Okay, this is input, and then this is the output. All right, so this is the this is the input waveform. Okay, from this AC waveform, okay, go for this full wave rectifier. All right, so will be like this lah. Okay, will be like this. That means on the negative cycle will be invert to the positive. Okay, so this one will be from negative to the positive cycle lah. Okay, that is the function of the rectification lah, the full wave rectification So will be invert the negative cycle to be the positive cycle So if you see the flow for the direction, okay, I change the color here, right? So the flow will be like this Okay, will be allowed the positive So actually this is the original form the original flow of the current Alright, so you can see this is the flow. Okay, will be like this. This is we call the positive cycles. Okay, alright. That means for the positive cycles, okay, for the positive cycle, so will be effect the D2 and D3. So that means the D1 and D4 will be open circuit will be open will be open. So no function for the D1 and D4 because the open So D1 for the D4 will be on the negative cycle or the negative cycle Okay, so that is the flow you can see the flow for the full wave rectifier. So the will be on for the positive cycle, so will be for D2, okay, D2, and then go for D3, then go for the output. Okay, that is the flow of the current Alright, so from this equation, okay, actually we have similar like before this, we have ADC, okay, 1 over T, integration from 0 to T, okay, so this is equation, the IT, okay, dt, okay, and then 1 over T because 2 pi, alright, integration from 0 to 2 pi, 360, alright, IP, sin T dt lah. Okay, so this is IP. Okay, and then from this derivation, so I just skip this derivation, and then at the end, so IDC equals to 2 IP over pi. Okay, and then O equals to 0.636 IP. Okay, that means 0.636 come from 2 over pi. Okay, 2 over pi multiplied by IP. So this is a formula. So this is formula for full wave rectifier. For calculate the current DC is equals to 2 over pi multiplied by IP, or 0.636 IP. Okay, and then you can use your Okay, here we can ultimately current DC will be given. Okay, so we for question number 2, we want to find the current IP lah. So the current IP equals to 0.8 milliampere divided by 0.636. Okay, 636. So the answer will be 1.25. One is so will be 2 milliampere. Okay, that is for equation number 2. Okay, so actually current DC will be already given here. So this is current DC. Okay, 0.8. Okay, and then for this one, question number 2, we want to calculate the current peaks. Okay, so what is the peak value. That means the peak value lah, IP. So for the question number 2, we want to find the current IP. So using this formula, you can get the current IP here. Okay, current IP. So current DC will be already given here, 0.8 milliampere. And then this is formula. This is formula, is the standard formula. Okay, 0.636 IP. Okay, this is formula. IDC equals to 0 for full wave rectifier is a 0.636 IP. Okay, this is full wave. We have to remember. So this one full wave rectifier. For half wave is a 0.1318 IP. Okay, to calculate the current DC. Right. So this is formula for half wave. Half wave. Okay, this is full wave. Okay, that you have to remember lah. So how it come from this one lah. Okay, from the output of the rectifier. So from this one lah, the equation for DC, you have to calculate 1/T integration from 0 to T current IT dt. So from this derivation, at the end we can get this one lah. Okay, so this is equation for full wave rectifier lah. For you, just remember for the for this equation only. Okay, so the current DC equals to 0.636 IP for the full wave. Okay, for the half wave, okay, for calculate the current DC is equals to 0.318 multiplied by IP. This is for half wave rectifier. All right. Okay, so next we go for the question number 3. Okay, question number 3. Okay, so draw and design the AC voltmeter using the half wave rectifier for the 3 volts RMS range. Okay, so the DR solvers movement with the internal resistance of 500 ohms and the full scale current of the 1 milliampere is used. Okay, calculate the AC and DC sensitivity lah. Alright, so that is for question number. Okay, question number 3. Question number 3. First, you have to draw the skirt lah. Okay, so draw the skirt similar like question number 1. So we use the half wave, half wave rectifier. Okay, so but this one we have the multiplier resistor. Okay. Okay, this is question number 3. Okay, question number 3. So this is okay, our supply will be 3 volts RMS, will be RMS. Okay, so this is our RS, this is our IT, current total lah. So this is our diode, D1. All right, so will be given, okay, I full scale deflection is 1 milliampere. So that you have to remember lah. So if current in series, so current will be same lah. That's why the current IT equals to same lah with current full scale deflection. So will be 1 ampere. Okay, so RM is the 500s. Okay, for this one, for the meter, on the meter, 500s. Right. So this is the equation number 3. This is equation number 3. So first you have to calculate the sensitivity for DC. Okay, the formula 1 over full scale current, full scale current deflection. Okay, so this is formula for DC, sensitivity for DC 1 over current, full scale deflection. This means 1 over 1 milliampere. Okay, so equals to 1000 ohms per volt. Okay, this is for DC, DC sensitivity 1 over current. Okay, full scale deflection. Current full scale deflection already given here 1 milliampere. So 1 over 1 milliampere. So we get the 1000 ohm per volt. Okay, and then to calculate the sensitivity for AC is the formula. So you have to remember this formula, 0.45 DC. Okay. right? So this is formula to calculate the sensitivity for AC. All right, 0.45. Okay, 0.45 multiplied by sensitivity for DC lah. So automatically 0.45 multiplied by 1000 lah. Okay, so the answer will be 450 ohm per volt. Okay, that is for AC sensitivity. This one for DC sensitivity. So first we have to calculate the sensitivity for DC is 1 over full scale depletion. Okay, full scale depletion is given here 1 milliampere, and then the answer will be 1000. Okay, to calculate the AC for half wave, this is formula. Similar like before this, for the current, we have the 0.3. Okay, so for sensitivity for AC, we have the 0.45. Okay, 0.45 multiplied by sensitivity for DC. Yeah. Okay, sensitivity for DC 1000. So that's why 0.45 multiplied by 1000. So the answer will be 450 ohm per volt. Okay, and then last one we have to calculate. Actually, we have to calculate the RS lah. Okay, RS here. So we have to calculate the RS. So the RS you can use the formula or you can derive. Okay, this is okay. So example, if you want to find the RT, okay. So the RT. So this is from derivation. From RT. So what is the RT? So you can see from this one. So you can see these are RT. Okay. So this is our eyes. Okay, we can see from this one. Right, from this point to this point. So for RT is equals to RS plus with RM. Okay, because the RS and RM is the series. Okay, in the series. This one, you can see the flow. So the flow from eyes. Okay, this one. Okay, that's why you can see this RS is a series with RM. Okay, that's why for RT equals to RS plus RM. Okay, and then equals to VDC divided by current. Okay, so this comes from the formula V equals to ohms. Okay, ohms formula, right? Okay, so we want to calculate the R. Okay, the RT here. So that's why voltage here. So voltage here divided by current. Okay, current total lah. Because this current T and current IDC is the same because the series. The series. So if you put current here, also the current IT will be same with this one. Okay, that's why the current will be same. Okay, for IT and full scale depletion is the same because in current in series. Okay, current in series. Okay, that's why the answer will be RS. From this one you can derive lah. Okay, so from this one 0.45. Okay, RMS V RMS. Okay, divided by current full scale depletion. Full scale depletion, okay, minus with RM. Okay, so 0.45 multiplied by 30, okay, divided by 1 milliampere, okay, minus 500, okay, so equals to 13 kilo ohms. Okay, that is for RS. Or another formula. Okay, so this is come from derivation. This come from this one. Okay, this one. From this circuit. So first we have to calculate the RT. So that I mentioned to you RT here. So we can see from this point. This point to this point. So that means our RT will be RS plus with RM. Okay, or equals to calculate the RT. Also we can use this formula. So this formula. Okay, V RMS divided by current, so we can get the RT. Okay, using this formula ohms. So from this one, so you can calculate the RS. Okay, so calculate the RS. So this one will be minus with RM. Okay, this is a formula lah. So another formula straightforward. Okay, so this is okay, the RT. So Okay, this RS equals to AC multiplied by range minus RM. Okay, so AC 450, range, our range is the 30 minus 500. Okay, so equals to 13 kilo ohms. Okay, so this is another formula lah. Okay, so another formula we can use this one. So we can use the sensitivity for AC multiplied by range minus with RM. Okay, we can get the RS lah. We can get the RS. Okay, so this is another formula. Okay, we can use this formula or we can use this formula lah, derivation. So this one, from this one is the derivation from this circuit lah. Okay, so this is for question number 3. So this is question number 3. Okay, so next we go for the question number 4. Okay, question number 4. Draw and design the AC voltmeter using the full wave rectifier for the 50 volt peak to peak sine wave range. Okay, so the ensemble movement with the internal resistance of 500 and the full scale current of 200 microampere is used. Calculate the AC and DC sensitivity lah. Okay, so this one first you have to draw. Okay, draw. Okay, so this one will be similar like question number 2 lah. Okay, you have to draw the circuit. So this is our supply. Okay, this is full wave rectifier. Okay. Okay, so this is D2, D3, D1, D4. Alright, so on question number 2, we don't have the RS. So this one we have the RS. Okay. Okay, so this is our meter. Okay, so go for the D1. And then this one go for the D4. Okay, this one D4. So right, so this will be given. So the value will be given. So the current here. Alright, so this is 200 microampere, and RM equals to RM given will be 500 ohms. Okay, and then so the voltage here will be 50 volt the peak to peaks. Okay, so you have to remember so this one 50 volt. So for example, this is our supply. The measure is the 50 volt peak to peak. That means from this one to this one. Okay, from this point to this point is the 50. Okay, it's the 50 volt. That means here will be 25 volts and here will be negative 25 volts. That's why, so here will be 50 volt peak to peak. Peak to peak. That means here from the output, okay, from the input should be like this, peak to peak. This is 50 volts. That means for the peaks is the 25 volt. 25 volt. Okay, this is a V peaks is the 25 volts. But peak to peak will be 50. Will be 50 volt. Positive and negative cycle lah. Okay, alright. So if we go for the dimension 2 for the positive cycle, alright. So the positive cycles they will be flow like this. Similar like this. Okay, similar like before this. Okay, go for the D2 and go for the RS. Okay, and then go here and then go for the D3 and then go for the supply. Okay, so this is a current flow lah. Current flow for the positive cycle. Okay, for the positive cycle. Okay, so similar like this. If you can draw, it will be like this. Okay, so this is our RS. Okay, so this is our IT. Okay, so here IT equals to full scale deflection is 200 microampere. Okay, so the RM equals to 500 ohm. Okay, so to calculate the sensitivity for DC, okay, so 1 over current full scale deflection so equals to 1 over 200. Okay, 200 micro. So the full scale will be given 200 microampere. So using your calculator, so the answer will be 500. 5,000 ohm per watt. Okay, so this is sensitivity for DC. Right, so and then you have to calculate for sensitivity for AC is 0.9. So this is different, 0.9 multiplied by DC. Okay, so you have to remember this one. For half wave, okay, for calculate the sensitivity for AC is equal to 0.45. Sensitivity for DC. Okay, so for full wave 0.9 sensitivity for DC. Okay, this is standard formula for half wave, and this one for full wave. Okay, now we use the full wave. So for calculate the sensitivity for AC, 0.9 multiplied by sensitivity for DC. So you can get the 4,500. Okay, 4,500 ohm per volts. Okay, this is for sensitivity for AC. Right, so next we have to calculate the RS. Okay, the RS. Okay, so we can use the formula. Okay, before this, okay, for example, I said use the formula. Sensitivity for AC. This one AC. AC multiplied by range minus with RM. Okay, so as you know, sensitivity for AC is the 4,500. Okay, range. Okay, range. Okay, so make sure. So this is a voltage peak. So from range, actually we have to, this value is in the RMS. So from this one, we have to get the voltage RMS. So that means this peak divided I square root of 2. So this is for VRMS. Okay, that means here will be 25 divided by pi square root of 2 lah. Okay, so this is the RMS value. So make sure so this one in the RMS value. So the voltage actually the given will be peak to peaks. Okay, from peak to peaks you can get the peaks. Peak is the 25 volts, but this one is the peak, not the voltage average atau voltage RMS. Here maybe voltage average is here, something like this. So this is voltage peak. And this is our voltage RMS. So the formula for calculate the voltage RMS is the voltage peak divided by square root of 2 lah. Okay, so this is formula. Okay, and then multiply by 25 divided by square root of 2 minus RM equal to 500. Okay, RM given 500 ohm. Okay, so the answer will be 79 kilo ohm. Okay, 79 kilo ohm. So check the is correct. So or you can use the derivation lah. Okay, derivation from the circuit that we can see this one. Okay, so you can use this one. So for example, using the another formula to calculate the RS equals to 0.9 VRMS divided by full scale deflection. Okay, so 0.9 multiplied by VRMS 25 divided by square root of 2. Okay, over full scale deflection is 200 microampere. So this one is a RMS, sorry, missing this. Minus with RMS. Minus with 500 lah. 100 equals to 79 kilo ohm. Will be same lah. Okay, so will be same answer. So this one straightforward using the formula, this formula, or you can straightforward using the derivation lah from the circuit. Okay, from the circuit. Okay, so this is from the circuit lah. Okay, from this one. For example, you want to calculate this one. Okay, calculate. So that means we want to calculate the RS. So this voltage. So suppose this is RMS. RMS. Okay. So the calculate the voltage RMS is the 0.9 multiplied by VRMS divided by full scale deflection lah. So this is another formula. So this one, this formula comes from this circuit lah. Okay. Right. So this is a solution for the question number 4. Okay. So next, okay, we can go for the question number 5. Okay, question number 5 on the tutorial 3. So calculate the AC and DC sensitivity and the value of the multiplier resistor, okay, RS, required to limit current to the full scale deflection current in the circuit shown in the figure 1. Alright, so you can see on the tutorial, make sure you have the tutorial. So on the figure 1, okay. So you have to calculate the AC, DC sensitivity and the RS lah, similar like this one, similar like question number 4. Okay, for the number 5, okay, this is okay, question number 5. Okay, this is circuit, okay, circuit. This is our RS. Okay, this is RD. This is R1. Okay, this is our meter. Okay, so our meter full scale deflection. Full scale deflection is given here 1 milliampere. Okay, and then the RM will be 250 ohms. Okay, this one R1 will be R1 also 250 ohms. Okay, and then we have here another one, RD. So we have the another RD here. Okay, so this is 300 ohms. 300 ohm. This one also 300 ohm. Okay, so this is a resistor, resistor for diodes. Okay, the value for this RS. Okay, then this is a E. Okay, so our E will be 20 volts RMS, RMS. Okay. Alright, so first we have to calculate the AC, okay, sensitivity for DC, okay, straightforward 1 over full scale deflection, okay. Alright, so okay, sorry, for this one, okay, this one we have to calculate the okay, I first before we calculate, so we have to simplify it first. We have to simplify, okay, using the positive cycles, okay, similar like before this. If the positive cycle, you can see the direction. Okay, the direction of the positive cycle will be like this, will be like this. Okay, so will be here, and then the one current will be divided by 2 branch. Okay, for this one for full scale deflection and this one for IM. Okay, we call the I shine here, I shine, and then this one will go. Okay, will be combined again. So this one will flow combined again with this one. Okay, and then go straight to the supply. So this one will be ignored. Okay, so the diode D, okay, this one we assume D1 and D2. So the positive cycles, Okay, so the D2 will be open. Okay, this one will be open lah. Okay, will be open. So the current will be flow like this. Okay. Okay, will be like this lah. Okay, so if you draw, okay, change the color here. So we draw again, so it will be like this. Okay, so this is our RT lah. We assume as the resist total total. This is our E lah. Okay. Alright, so we have to calculate the RT here. This is current T. Okay. Okay, so to calculate the RT here, so we know, so this one, okay, this is a 1 milliampere. This one given 1 milliampere. Okay, so you can see for the this actually, if the voltage in parallel will be same, so this one, the voltage will be same, so R2 will be same. And then you can see this one, so the resistor here will be same. Okay, RM is the RM here will be given 250, and also R1 is the 250. That means voltage will be same, current will be same. Okay, so the current flow here 1 milliampere. So the current flow here also 1 milliampere because of the resistor here and resistor on RM is same. Okay, same value. That's why the current also the same. So the current will be here. Okay, current here 1 amp, here 1 amp. So that means our current total will be, okay, current total will be 1 milliampere plus 1 milliampere. Okay, so that's why our current total will be 2 milliampere. Okay, so this one we know given is 1 milliampere. So because of we know the resistor here is 250 and this one also 250. That means the okay, if you apply the voltage here, okay, so the voltage here will be same with the voltage here because of the parallel. So that's why the current will be same lah. So that's why current here will be same because of the resistor, okay, RM and R1 is the same. So that's why our current T will be 2 milliampere lah. And that's why you can calculate the sensitivity for DC is equal to 1 over IT lah, our full scale deflection. Full scale deflection is 2 milliampere, okay, equals to 500. Okay, this one is 500 ohm per volt. Okay, this one for sensitivity for DC, and then calculate the sensitivity for AC. Okay, this is 0.45. Okay, multiply by sensitivity for DC lah. Okay, 0.45 because this is half wave rectifier. Multiply 500. Okay, so the answer will be 225 ohm per volts. Okay, so this is a sensitivity for the AC. So next we have to calculate the RS. The RS. Okay, the RS or the first we have to calculate the RT. So the RT here. Calculate the RT. So when I mentioned to you, so when we assume this point to this point, okay, so to calculate the RT here, okay, we can see from this one. So that means our RT, okay, we can see this one, RS, okay, will be plus with this one, RD, and parallel with these two. Okay, that means RS plus with RD. Okay, this one, we call the RD here. Okay, so plus with parallel of R1 parallel with RM. Okay, this is R total lah. This one to get the R total here. So this one you can see from this one. Okay, so RS plus, okay, because of the series, okay, with RD plus RD and then plus, but parallel of to this one parallel RM and R1. Okay, so first we have to calculate the R1 parallel with RM lah. Okay, so as we know, RM is 250 and RM is 250. 1 over 250 plus 100 250. So the answer will be 1 over 150. So we invert. So the answer will be 100 ohms. Okay, 125 ohms. Okay, for parallel R1 and R2. Or you can use the formula lah. Okay, R1 multiplied by RM divided by RM plus RM. R1 plus RM. So this is another formula another formula to calculate the parallels. Okay, or you can use straightforward using 1 over RM plus 1 over R1, and then you have to invert lah, because this is 1 over parallel. That's why after you get this one, you just invert. So that's why you can get this value lah. Okay, 125. Okay, 125. So RD also already given. RD is 300. Okay. So and then we can from this one actually we can calculate the RT. Okay, so the RT you can calculate using the formula lah. Formula VDC divided by current total lah. Okay, this one current total. To get the RT, we know the current here, and we know the current, and we know the supply here, so we can calculate the RT lah. Okay, so the voltage 0.45 multiplied by 20 okay, because this is 20 volt RMS or segi volt RMS divided by 2. Okay, 2 milliampere. IT is 2 milliampere. So the RT is the 4.5 kilo ohms. Okay, and then from this one we can get the RS lah. Okay, so that means RT minus with RD, okay, plus R1 plus RD plus RM, sorry, parallel. So 4.5 kilo minus, okay, this one RD is 300 plus 125. Okay, so the answer will be 40475 ohms. Okay, so that is the answer for RS. So okay, so it will be same. Answer will be same. So you can check on the answer. So the answer will be for RS multiplied resistor will be 4075 ohms. Okay, that is for calculate the RS. Okay, all right. Okay. Okay, client. So this is for the solution for the question number 5. Okay, first use the half wave. Okay, half wave rectifier. Okay, so next we go for the question number. Okay, number 6 is the theory. So you can see this one. So the theory. Okay, number 6, describe how shine resistor R1. Okay, this one. How resistor shine, this one R1 in the circuit shown in the figure 1. Okay, can increase the current flow. Okay, the current flow through the R positive half cycle, so that the diode is operating in the more linear portion of its characteristic curve. Okay, as you know, so you can see this one, this R1, okay, so this is a theory. So that mentioned to you, you can okay, so from this equation, okay, you can know. So when we increase the number of this resistor, okay, so the current will be, okay, when we increase the number of the resistor here, so the current will be reduced. Okay, the current will be reduced. Okay, when we increase the current, so the resistor will be reduced. So this is a relationship lah. That's why the answer you can answer from this one lah, this equation, the Ohm's law. So when the resistor is increased, so will be reduced on the current flow here lah. Okay, the current will be flow. Okay, will be reduce the currents. Okay, so that is the answer for the question number 6 lah. right? So based on this equation, the Ohm's law lah. Okay, you have to know the relationship. So when we increase, okay, when we increase number of resistor, so the current will be reduced. Okay, the current will be reduced because of the function of the resistor to reduce the current flow. The current flow on the resistor lah. So for example, if we have here, okay, so number of resistor will be increased, and then the current flow here will be reduced lah. Okay. Okay, that's for question number 6. Okay, number 6 is just a theory, just a theory. Okay, right. So we go for the question number 7. Okay, question number 7. Okay, so calculate the AC and DC sensitivity and the value of the multiplier resistor required to limit current to the full scale deflection current in the circuit as shown in figure 2. Okay, figure 2. Figure 2 ni is the full wave rectifier. Okay, all diode have the forward resistance of 300 ohms and infinite reverse resistance lah. Okay, that means infinite reverse resistance if the negative cycle, so resistor will be open for D1 and D4 will be open open circuit. Okay, so the concept will be same like this. Concept will be same similar like figure question number 5, but we use the full wave rectifier. Full wave rectifier. Okay, so this is question number 7. Okay, first you have to draw. Okay, based on this is okay, so this is D1. Sorry, this is D2, D1, D4, and this one, this 3. Okay, so go for RS. Okay, this is our R1. Okay, you can check on the figure 2. Okay, so this is our meter, and then okay, so go for the D3 and this one go here. Okay, so this is full scale lah. Okay, if you can see this one, the similar like before this. Okay, so the current flow will be like this. The current flow. Okay, go for D2, go for this one RS, this one R1. Okay, so the given R1, okay, same 250. So this is RM 250. So the current, okay, current full scale deflection here is the 1 milliampere. Okay, so current will be flow. Okay, go here and will be split by 2. Go here and then here will be combined again. We combine this one and this one. Okay, go here. Okay, go for the D3 and go for negative. Okay, so this is positive cycle. This is a positive cycle. Okay, so you can see if reverse resistance infinite lah. That means for reverse, so this one will be open. Will be open. This open circuit lah. That's why we have infinite resistance. So will be open circuit. That's why we focus on the positive. Okay, positive half cycle lah. Okay, so this is similar like question number 5. So the current, okay, you can draw again. Okay, maybe you can draw again. So this is our supply. I'll change color here. Okay, so this is our, you can see this one. This is our RD. Okay, this is our RS. Okay, this is R1, and this is RM lah. Okay, and then this is another one. This is RD3. Okay, so this is RD1. Okay, sorry, this is RD2. Okay, this is RS here. Okay, and then this is RD3. Okay, this one RD3, and then this is R1, and this is RM. And go for supply lah. Okay, this is a circle we can draw again for the positive. This is positive cycle like this lah. Okay, you can calculate you can convert into this one calculate to this one. Okay, RT go to this one. This is RT, and this is our supply lah to get the current here. Current T. Okay, so this is from this circuit we can convert lah to calculate the RT. Okay, the RT will be, okay, you can see from this point this point to this point. So from this point we can see, okay, we can see that RD1 RD2 series with this one RS, okay, series with RS and plus with parallel of these two, and then series with RD3. Okay, so this is for RT lah. That means RT, you can see this one RD2 plus RS plus parallel of R1 and RM plus with RD3. Okay. Actually, is the RD is the same resistance. That means you can simplify it like this plus 2 RD. Okay, we can see as the RD plus parallel of R1 and RM. Okay, R1 and RM. So that is to calculate the RT. Okay, but first we have to calculate the sensitivity for DC lah. So similar like similar like for this IT. Alright, so same 2 milliampere. Okay, so the answer will be 500 ohm per volt. Okay, and then calculate the sensitivity for AC is 0.9. DC sensitivity for DC is equals to 0.9 multiplied by 500. Okay, so the answer will be 150 ohm per volt. Okay, ohm per volt. So this is sensitivity for AC. Okay, so you have to remember lah, for full scale we use the 0.9, half rectifier we use the 0.45. Okay, 45, the constant here. Right. So next we have to calculate this one lah, the RS. So first we have to calculate the RT lah. So the RT, okay, first we can calculate the R shine. Okay, so this one R1, okay, parallel with RM. Okay, so the answer similar like before this 120. Okay, so the 2 RD is the 2 multiplied by 300. Okay, it's a 600. Okay, because this one is the given is a 300, and also this one is 300. Oh, that's why you can get the 500. And then for RT, okay, 0.9 multiplied by 20, okay, divide by 2m. Okay, so from this one you can get the RS lah. So the RS here from this equation, the RS equals to RT minus 2RD plus R1 plus RM. Okay, this means RT. Okay, you can calculate what is the RT. Okay, so RT 9 kilo. Okay, this one is 9 kilo ohms. All right, and then from this equation we can calculate the RS. Okay, so 9 kilo minus with 600 plus 150 125, sorry, 125. So the answer will be 8.275 kilo ohms. Okay, so that is RS. Okay, so this is for question number 7. The answer for question number 7. All right, so next we go for the question number 8. Okay, number 8. Okay, so you can read on the tutorial 3, number 8. An AC voltmeter is to be used to measure the RMS voltage across the 15 kilo ohms, okay, resistor in the circuit shown in the figure 3. Okay, if the voltmeter use half wave rectification and 100 microampere, the oscillatory meter movement, if in its set on its 10 volt range, okay, and if Rm equals to 1.5 kilo ohms, okay, what reading will be obtained? Okay, what reading will be obtained? So that means the meter on the meter, what's the value for on the meter movement? So okay, we go for the question 8. Okay, so for the question 8, okay, first we have to draw. Okay, draw. Okay, so this is our circuit. Okay, this one is the given 20 VRMS, VRMS. Okay, this one R1. Okay, it's a 25 kilo ohms. Okay, this R2, as soon as R2 is the 50 kilo ohms. Okay. All right. So if first we want to measure the voltage, okay, voltage across the R2. Okay. So if you want to measure the voltage R2, we can calculate the using the voltage divider rule, right? We call the voltage divider rule, voltage divider rule, right? Okay, so to calculate the voltage VR2 equals to R2 R1 plus R2 multiplied by V RMS here lah. So that means okay, 15 kilo, okay, 25 plus 15K. All right. Any question? All right. So multiply by 20. 20 equals to. Okay. So this one. Okay. Using your calculator. Okay. So try using your calculator. Okay. What is the voltage here? Voltage across R2. Okay, kali multiply by 20 divide by 15K plus 25K. So 7.5. Okay, this one is a 7.5. Okay, 7.5 volts. Okay, that is for calculate the voltage here, right? And then if we put the meter here, okay, we put the meter here. Okay, so for the meter we have the RM. Okay, we have this one. If okay, this one is still not connected to the meter, but second we have connected to the meter here. So RM equals to okay, RM equal to 1.5 kilo ohms. And then we use the 10 volt range, okay, 10 volt range. Okay, this meter we use the 10 volt range, and then hundreds. Okay, we use 100 microampere. Okay, we use the 100 microampere lah. Okay, this is we call the full scale current here. Current here, current full scale deflection lah. So 100 RM, and then range is the for 10 RMS. Okay, so next, okay, using the formula, all right, you can calculate the here V total. Okay, so actually V, you can see this one, so V total actually you can see this one. So the RS plus with RM lah. Okay, so equals to 0.75 multiply V RMS Okay, by full scale deflection current. Okay, so that is 0.45 multiplied by 10. Okay, this we use 10 volts in ms 1 micro. Okay, then we can get 45 kilo ohms. Okay, and then we can get R equivalent here. Okay, as you know, this is a R equivalent here. So 15. Okay, parallel with 35. Yeah, you can see this one. So here we have RS 45 kilo. Okay, so parallel, the answer is the 11.25 kilo ohms. Okay, and then you can calculate. Okay, after you can get the resistance here, equivalent here, so you can using the V same voltage divider rules. Okay, VR2. All right, so similar, but the resistance will be different. 11.k 11.25k plus 35 k multiplied by 20. Okay, so the answer will be 6.2 volts. Okay, so you can see so if we put the meter here, so reading will be get the 6.2. Compare this one so if we don't put the meter reading here, so suppose on the theoretical, so the reading should be 7.5, and we put the meter here, so will be reduced to 6. Okay, 6.2 lah, 6.2. Okay, to increase this one, okay, to increase this one, that's why we can change normally we can change the sensitivity lah, sensitivity of the meter. Okay, that's why this is another technique lah. So how we want to improve so on the theoretical, suppose the V2 is the 7.5, but when we put the meter here, okay, we put the ensemble meter here, so the reading we get is the 6.2. Okay, 6.2 here. So will be difference lah. Okay, 7.5, 6.2. So to increase this value to the actual, so we can increase the number of sensitivity lah. So that's why we have the AC sensitivity or DC sensitivity lah. So there's another method lah how to increase the value here. So but the answer here, when we put the meter, so the answer will be 6.2. Okay, 6.2 volts. Okay, so you can check the answer will be 6.2 lah. This is the same Okay, so okay, that's all for today. I think we stop on the question number 8. So I will leave you another 2 questions for you to try. Okay, I think the question number 9, okay, will be same like question number 8. Okay, you can try this one after this. All right, so the question number 10, okay, also similar lah. Okay, similar like question number 8, but this one we use the full wave rectifier. Okay, rectification. Okay, and then we set the meter movement is 100 microampere, and the range is the 150 volt range. Okay, and then also we put the limiting error. All right, so for the question number 10 is your another assignment lah. So that means, okay, so you have the 2 assignment First for the question number for the tutorial 2, and then for the tutorial 3 is the number 10 for your assignment So you have to try lah. So you have to try the question number 10 for tutorial 3 and question number 8. I think number 8 for the tutorial 2. Okay. So that's all for today. Ada soalan? Alright, so if not question, so I will stop here. Alright, so So for today, you just focus on for tutorial 3, we focus until question number 8, and then your assignment will be on the number 10. So number 10 on your assignment, you have to try. Okay, you can submit next week lah. Okay, for next week. So that means for this week we have 2 assignment lah. So for the tutorial 2, another 1 question, and tutorial 3, another 1 question. So that's why you have to try lah. Okay, and then you have to submit by email to me, maybe next week lah. So next week is okay. On the Friday next week, so still you can okay lah, right? So for the attendance, wait, okay. So attendance similar. You can use, okay, you can use the link that I share on the groups. Okay, for the attendance, attendance you can fill up the Google Forms. Okay, that I forward yesterday. Also, don't worry, I already take on the tips lah. Okay, we have 2 types. Okay, 2 types of the attendance lah. Okay, if you not okay, you can also write the Google form. Okay, Google Forms, right? So yesterday I already shared the video. The video for the next topic is the oscilloscope. Actually, the oscilloscope a lot of theory. That's why for the topic for the oscilloscope you have to read lah, or you can see on the YouTube challenge. Okay, sorry, YouTube channel. So I will share the link. Okay, share the link for the explanation on the theory about the oscilloscopes. Okay, but for the oscilloscope, the calculation is only how to use the oscilloscope, how to measure the signals. Okay, how to read the waveform from the oscilloscope. That's on the calculation lah. On the calculation, the rest is the theory lah. What? Okay, for example, like oscilloscope, we use on our topic will be on the analogs, on the analog oscilloscopes. Okay, but nowadays they mentioned to you. So nowadays a lot of oscilloscope we use the digital. Okay, similar like FKE. So actually on the FKE we have digital oscilloscope lah. Okay, digital oscilloscope compare than our topic. We focus on the analogs. Okay, analogs oscilloscope lah. Okay, you can see on the link that I will already shared on the groups. Okay, that is for theoretical for oscilloscope lah. Okay, so that's all for today. So next week we will start. We will discuss about the oscilloscope, the new topics for oscilloscope, and also we go for the AC and DC bridge. Okay, that's all for today. So thank you very much. Okay, and Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you.
Thank you, Doctor.
Okay, Doctor.
Okay, so if you have any question, don't worry, so you can WhatsApp me lah. Kalau ada soalan, okay, tak faham, tak sempat nak tanya sini, boleh WhatsApp saya. Okay, thank you. Okay, bye bye.